This PowerPoint is going to be on well math. As always, I claim no ownership to any of the questions and material presented in this video, as everything I find is sourced off the open internet. In the following slides, I, to the best of my ability and knowledge, have presented the proper formulas and answers to these questions. Like I said, I'm making these as a study help for me, take my exam. It's helping cement things in my mind. If it helps you out too, that's great. So the formula for the well math, specific yield gallons per minute per foot, with well yield gallons per minute divided by the drawdown. We're going to use this formula to answer different questions in different ways. We'll have to rearrange it depending on your knowns and your unknowns. This is not on the Florida formula sheet actually, but still good things to know. I mean, sometimes when you take a test, they actually will give you a formula that's not already on the sheet, which I have seen in the past. The second formula we'll be using is for finding drawdown. And drawdown is equal to the pumping water level minus the static water level. Question number 1. A well produces 125 gallons per minute. If the drawdown for the well is 20 foot, find the specific yield in gallons per minute per foot. So we're going to get our known and our unknowns. What we know, the well produces 125 gallons per minute, and the drawdown is 20 foot. What we're looking for is the yield. The equation for specific yield, gallons per minute per foot, is well yield divided by drawdown. Put your 125 gallons a minute divided by 20 feet, and your specific yield is 6.25 gallons per minute per foot. Question number 2. Find the specific yield in gallons per minute per foot if a well produces 46 gallons per minute and the drawdown for the well is 17 foot. Again, I always like to pull my known and my unknowns out of a word problem. So what you know is that you're 46 gallons per minute, you have 17 feet of drawdown, and you're looking for your specific yield. So that will tell you what equation you want. Specific yield is equal to well yield gallon per minute divided by drawdown in feet. So you plug in your 46 gallons per minute divided by your drawdown of 17 feet, and that gives you a yield of 2.7 gallons per minute per foot. Question number 3. Find the specific yield in gallons per minute per foot if a well produces 80 gallons per minute and the drawdown for the well is 24.5 feet. Pull out your known and unknowns. 80 gallons per minute, 24.5 feet. You're looking for the yield. Specific yield gallons per minute. It's well yield divided by drawdown. 80 gallons per minute divided by 24.5 feet gives you 3.27 gallons per minute per foot. Question number 4. Find the drawdown of a well if the well yields 215 gallons per minute and the specific yield is 19.6. So we're going to pull our known and our unknowns out of this equation. What we know is the well yields 215 gallons per minute and the specific yield is 19.6 gallons per minute per foot. What we don't know now is the drawdown. This is the equation we were using earlier. We need to rearrange it for drawdown. So you're going to take your drawdown to one side and your specific yield, you're going to switch them. So drawdown in feet is equal to well yield divided by specific yield. And then your gallons per minute will cancel out and you'll be left with feet. So here's our equation. Plug in your numbers. 215 gallons per minute divided by 19.6 gallons per minute per foot. Gallons per minute will cancel out. And your drawdown is 10.97 feet. So, still a question about wells. Just had to rearrange the formula that you're given. Question number 5. Find the drawdown of a well if the well yields 408 gallons per minute and the specific yield is 22.1 gallons per minute per foot. We're going to find our known and our unknowns. Your unknown is the drawdown. So here's our formula. The drawdown in feet equals well yield gallons per minute divided by specific yield gallons per minute per foot. Plug your numbers into your equation. 408 gallons per minute divided by 22.1 gallons per minute per foot. Gallons per minute are going to cancel out. And your drawdown is 18.46 feet. Question number 6. Calculate the well yield in gallons per minute given a drawdown of 8.2 feet and a specific yield of 48 gallons per minute per foot. Again, pull your known and your unknowns out of your word question. So what we know is the 48 gallons per minute per foot and the 8.2 feet of drawdown. What we don't know is the well yield. So we have our original starting formula of specific yield gallons per minute per foot is equal to well yield gallons per minute divided by drawdown feet. Going to have to rearrange this because we want to find the well yield in gallons per minute. So well yield gallons per minute is equal to the specific yield gallons per minute per foot times drawdown in feet. Remember, this is gallons per minute over foot, so the feet will cancel out, and you'll be left with gallons per minute. The new formula, well yield gallons per minute, is equal to specific yield gallons per minute per foot times the drawdown in feet. All right, so we're going to plug our numbers into our formula. 48 gallons per minute per foot times 8.2 feet. Remember, the feet will cancel out. You are left with a well yield of 393.6 gallons per minute. Question number 7. Calculate the well yield in gallons per minute given a drawdown of 5.5 feet and a specific yield of 57 gallons per minute per foot. Pull out your knowns and your unknown. You have a drawdown of 5.5 feet and a specific yield of 57 gallons per minute per foot. What you don't know is your well yield. So a rearranged formula, well yield gallons per minute is equal to specific yield gallons per minute per foot multiplied by the drawdown in feet. Plug in your numbers, 57 gallons per minute per foot times 5.5 feet. Feet are going to cancel out. You're left with 313.5 gallons per minute. Question number 8. The pumping water level in a well is at 55 feet. If the static water level is 38 feet, what is the drawdown for the well? All right, we're going to pull our knowns and unknowns out. Our pumping level is 55 feet. Our static level is 38 feet. We're looking for the drawdown. The formula for finding a drawdown is the pumping water level minus the static water level. So you're going to plug your 55 feet in, minus your 38 feet, and it gets you a drawdown of 17 feet. Question number 9. What is the drawdown for a well that has a static level of 23.45 feet and a pumping water level of 46.8 feet? Pull your known and your unknowns out. Pumping level is 46.8 feet. Your static level is 23.45 feet. You're looking for your drawdown. Formula for drawdown is pumping water level minus static water level. Plug your numbers into your formula. 46.8 feet minus 23.45 feet. And that gives you a pump drawdown of 23.35 feet. Question 10. If the static level in the well was 104.5 feet and the drawdown was 11.33 feet, what was the pumping water level in the well? Let's pull your known and your unknowns out. What we know is the drawdown of 11.33 feet and the static level of 104.5 feet. What we don't know is the pump level. This is our original formula for drawdown. We're going to have to rearrange this. So you rearrange it, your pumping water level is equal to your drawdown plus your static water level. So this is the formula rearranged. We're going to plug in our numbers. 11.33 feet plus 104.5 feet. Do the math. Your pumping water level was 115.83 feet. Question number 11. The pumping water level in the well was 152.07 feet. If the drawdown was 9.01 feet, what was the static water level in the well? So we're going to find our known and our unknowns. So you have your drawdown of 9.01 feet and your pumping level of 152.07 feet. This time we're looking for the static level. Again, the original formula, drawdown is equal to pumping water level minus static water level. We have to rearrange this formula so that we can find static level. Static water level is equal to pumping water level minus the drawdown. So we have our formula rearranged. We're going to plug in our numbers. 152.07 feet minus 9.01 feet. And that gives you a static water level of 143.06 feet. Alright, so that was a good overview of well math questions using the formula for specific yield and drawdown. Different versions wanting to be answered, so we had to rearrange them. Like I said, this is helping me study to take my exam. I'm going to keep putting them out because they're helping me. If they help you too, great. Thanks.